Second part of this lesson deals with diffraction grading. And a diffraction grading simply means that we're going to take a piece of glass or a piece of plastic or something, and instead of actually cutting slits through it, we're just going to scratch a line in it. And if we scratch a line in it, it acts like a diffraction grading. It acts like a slit. You can do this if you have very precise machines. You can cut, so you can take a piece of glass or a piece of plastic or plexiglass or whatever you're going to use, and you can cut thousands and thousands of slits or thousands of lines on it to create diffraction, or to create diffraction and then interference. And you can do this. There are some of these diffraction gratings have 10,000 lines per centimeter. So in 1 centimeter, they will have 10,000 of these little lines. And what they do is they produce really sharp and precise interference patterns. So that's why we use diffraction. Instead of just using 2 slits, let's use 10,000 slits and see, and that will produce a much better pattern for us, whereby we can measure, or we can do Young's double slit experiments, but it's now multiple slits. So that's essentially what a diffraction grating is. So there's a picture of what it looks like, and it will just create a sharper image or sharper interference pattern. And usually these diffraction gratings are given in values like this: 600 lines per millimeter. So in 1 millimeter, you'll have 600 scratches that creates the diffraction and then the interference. And what you have to do for diffraction gratings is figure out what the D value is for the diffraction grating so that you can use it in the formulas you learned in the first part of this lesson. So example number 3 says, determine the D value for a true diffraction shown in illustration 10 that is labeled as 600 lines per millimeter. And there are multiple ways you can do this. The way that I like to do it is set it up as a proportion. So, or at least I'll show you this so that you can figure out the principle behind it. So if there are 600 lines, now this says 600 lines per millimeter. And so I'm not going to write 1 millimeter. I'm going to write 1 times 10 to the negative 3 meters, because we want the D value in, D is the distance between the slits, we want it in meters. So I'm just going to convert that 1 millimeter. This is 600 lines per 1 millimeter, which is the same as 600 lines per 1 times 10 to the negative 3 meters. If there are 600 lines in that distance, what distance is 1 line? So I'm just going to put X, even though it should be D, really, right? It should be the variable D, because X is something else, but we just use X in math so much. And then you cross multiply and divide. So what you end up doing is getting 600X equals 1 times 10 to the negative 3, and then you're going to go 1 times 10 to the negative 3 divided by 600, and you're going to get an answer of 1.67 times 10 to the negative 6 meters. So that's one way that you can do it. Set it up as a proportion, or you can just inverse that 600, 1 over 600, and then change it to meters. But I just wanted to show you this way so that you can see the proportion and the rationale. If there are 600 lines in 1 times 10 to the negative 3 meters, then how far is it between? Now, it's not that it's between 2, it's 1 line. So you just put 1 line there, don't put 2. So now that we got the distance, the D value for that, then we can use that in example 4. It says use the D value you just calculated to determine the color of light from the central bright fringe to the first fringe is 17.5 degrees. So in other words, at D value, which we just calculated, theta is 17.5 degrees, which you should be using this formula, but we'll just do it anyway. And then N is 1. So plug the numbers in. and you end up getting 502 nanometers, which coincidentally is green. That was totally unintentional that it wrote that in green. So this is basically green light. All right, and that ends the super interesting concept of diffraction in Young's double slit experiment. And again, I strongly recommend you go on YouTube and watch some videos because it's really fascinating.